Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice in using the old school approach to performing hypothesis testing and constructing confidence interval estimates for two population standard deviations or variances. Let's get started. So, to practice using this F-test, we're going to look at an example that we've already seen in previous mini lectures involving creativity research. So you've got your research subjects who were asked to think about creative uses for a brick. They're separated out into one of two different rooms. One is the red room, the other is the blue room, and they, give out responses to creative uses for a brick. And the responses are judged by a panel of judges. So then you get the, sample statistics calculated. And you can see those here. They're the same ones that we've seen before. And we're going to test at the 5% significance level the claim that the standard deviation of both groups is the same. In other words, that even though we see a difference here with the samples, okay, we're testing the standard deviation of the population, okay? And we're going to say that even though these are different, that's just a fluke of the sampling that we took, that really in actuality the population standard deviations for these two groups are going to be the same. So in other words, the amount of variation that we see in each of these groups is going to be identical. The first thing we do, always think about the claim when making our hypothesis. So what is the claim? Well, the claim here is that standard deviation of the creativity scores for subjects in the red room is the same as the standard deviation for subjects in the blue room. Now notice how we've assigned the red room to be sample 1 and the blue room to be sample 2. That's because the standard deviation for those in the red room is greater than those in the blue room. If I go back here, you can see here this is the greater standard deviation, and so it's going to have the greater variance, and therefore that makes the red room the first group, and the blue room is then going to be the second group. So we're going to write our claim to say that they're going to be the same. So sigma 1 is going to equal sigma 2. But typically when we're doing our F-test, we express this in the terms of a ratio. So that's going to be the same as saying sigma 1 divided by sigma 2 equals 1. If I just take this expression, divide both sides by sigma 2, this is what I get coming out. The null hypothesis, always a statement of equality. So we're going to write this, but this is the symbolic representation of our claim. So for our alternative hypothesis can't be that. So we're going to have to take the complement of our claim. And so the complement of the claim that they're equal is going to be that they're not equal to each other. And of course, not equal there in our alternative hypothesis means that we have a two-tailed hypothesis test. To test the claim, we're going to evaluate our test statistic. So we're just going to take the variance for the first sample, divide it by the variance for the second sample. And to do that, we were given standard deviations, not variances. So we have to square the standard deviation for each of those samples to get the variance. And so there you see we plug the numbers in. Note the larger of the two numbers always goes on top. The F-score is never less than 1. And the way that we get that is by always putting the larger of the two numbers on top. So make sure that larger number goes on top of your fraction. Then when you divide that out, you get 2.371. And then we can use technology, or if you have an F distribution table, you can use the table as well to calculate the p-value from the test statistic, because the p-value is just the area in the tail of the distribution that's bounded by the test statistic. So there's our p-value 0.0129. We compare that with our 5% significance level, and we find that the p-value is less than alpha. Therefore, we're inside the region of rejection, and we're going to reject the null hypothesis. If we compare a test statistic with the critical value, we're going to get the same thing out. Okay, so here's our F distribution, and notice how here we've got our critical regions. So we've got 5% split among two tails. So 2.5% is on the left tail, 2.5% on the right tail. And our test statistic 2.371. 2.371 is going to be off over here in the right tail. You're inside the tail, therefore you're inside the region of rejection, and you reject the null hypothesis. So either way you look at it, it's going to come out the same way. So we reject the null hypothesis, so there is sufficient evidence. We have a two-tailed test, so we warrant rejection of the claim, and the claim is that the standard deviations of both test groups are the same. Confidence intervals, we can reach the same conclusion with the confidence interval. First, we're going to find our F values, and we do that by using StatCrunch. We can use this with an F distribution table, but it's much easier to just use StatCrunch. So we get our critical F values out of here, and because we have a two-tailed test, we've got this between option selected. So because the calculator in StatCrunch is calculating the area between the tails, we want the complement of our significance level to go here for the area. So 95% goes in here, and then we see we've got one critical value on the left and one critical value on the right. So the way this typically works is the one on the left is labeled F sub alpha over 2, and the one on the right is labeled F1 minus alpha over 2. It's the complement of the first one. That's just the notation that's used. Next, you're going to substitute into the general form. So here's your general form. And again, just like we saw before with standard deviations, okay, especially with that chi-square distribution, we've got the critical value on the left is going in the denominator on the right. The critical value on the right is going in the denominator on the left. Okay, so you got to flip-flop that around. But once you do that, just plug in the numbers you got, and out will come your lower and upper limit for your confidence interval. The key question here is 1 inside or outside the confidence interval? Here 1 is outside the confidence interval. So therefore there's always going to be a difference between the two variances. They're not going to be the same. Okay, so therefore we can say, yes, we've got the same conclusion that we had before with the hypothesis testing, which is that the population standard deviations are not going to be equal. And that brings us to the end of this mini lecture. I hope you found it helpful. You could find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.